Hello everyone, I'm Paul and today we're solving problem 2563, count the number of fair pairs. So we're given an array and two integers, lower and upper. And we are trying to return the number of fair pairs. So a fair pair has different indexes and the sum of its values is greater or equal to lower and smaller or equal to upper. So the first thought that comes to my mind is to apply a double for loop, and that will require a time complexity of big O of n squared, but the problem is down here in the constraints. So we know that nums.length is smaller or equal to 10 to the power 5. This means we need something faster than this. So one thing that we can do is first sort the array and then apply binary search. Okay, this approach will require a time complexity of big O of n log n, which will be enough for this nums length. So now let's go with a few examples. Now let's say initially we have this array and lower is 3 and upper is 6. The first step would be to sort this array, so this would be the sorted array. First we'll create two variables which we will call bounds. Let's say we have a low bound and a high bound. And to get the low bound, we'll take the lower value over here and do lower, which is 3, minus the current index, which is 0. So now the low bound is 3. And let's do the same for the high bound. We'll take the upper value, which is 6, minus the current value, which is 0. So this will be 6. Okay, so now we're doing binary search for each of these values, and we are trying to find what's the minimum index that includes values that are greater or equal than 3 and than the high bound plus 1, because we need to consider the upper values in bounds also. So here we add a plus 1. So now let's start with the 3, and I is here as we said before. Now we are doing binary search over this part. So left is here, right is here initially, and the mid pointer is here. Now we are checking if the mid value is greater or equal to the target, which is 3 in this case. So 4 is greater than 3, so we are moving the right pointer to mid minus 1. Now right is here, mid is here. We are working with the mid value, which is 1, and we are checking if 1 is greater or equal to the target. It isn't, so we move the left pointer to mid plus 1. Now the left pointer is here, right pointer is here, and mid pointer is also here. So we are working with the 4. We are checking if 4 is greater or equal to 3, and it is. So we move the right to the left of the mid pointer. Now right is here, and once we reach a point where left is greater than right, we return the left pointer. Okay, so this binary search with a target of 3, we return a 2, because this is index 2, index 0, index 1, and index 2. Now we need to do a binary search with high. So left pointer is here, right pointer is here in the last index, midpoint is here. So we're checking if 4 is greater or equal to the target, which is 7. It isn't, so we update the left pointer over here. Now left pointer is here, the mid pointer is here, we're working with the 5. 5 is still smaller than 7, so we update left here. Now left, right and mid pointer are here, and 7 is equal to the target, which is 7. So we move right pointer to the left of the mid pointer. And once left pointer is greater than right pointer, we return left pointer. So the result of this is 5. Now let's see what this means. Remember, we were here at index 0 and low is 2, so low is here, and high is 5, so high is here. And given that we added 1 to high previously, what this means is we are taking every number from low to high minus 1. So let's say high is here. What this means is we could take any pair which includes the current value at I and any value in between low and high. So here we could include 3 pairs in our results that would be in bounds. Okay, now let's see what this means. So if we take 0 and 4, the sum is 4, and that's in between 3 and 6, so that's valid. Here we can take 0 and 4 also, and that would still be valid. And if we take 0 and 5, that's also between 3 and 6, so it's also a valid pair. So in this case, we have 3 valid pairs that we can add to a result. And this is the same as saying high minus low valid pairs. So here we can add to the result 5 minus 2 valid pairs. So now the result will be 3. Now the I pointer is here, and we want to check for the low and high bounds again. So lower, which is 3, minus the current value 1 is 2, and upper, which is 6, minus 1 equals 5. So now we will do a binary search to find the minimum index, which includes a target of 2 and a target of 5 plus 1, because remember, upper should be included. So now we are doing binary search with this part only, and left is here, right is here, mid is here, 4 is greater than the target, which is 2 in this case. So now the right pointer should move here. Now left, right and mid are here, and we are checking if 4 is greater or equal to the target, which is 2, and it is. So we move the right pointer to the left of mid here. And now left is greater than right, so we return the left pointer, which is 2. Now we're doing binary search with this value, which is 6. So left is here, right is here, mid is here. 4 is smaller than 6, so we update the left pointer to mid plus 1. Now left is here and mid is also here, and 5 is smaller than 6, so we update left once again to the right of mid. And now left, right and mid values are here at the last index, and 7 is greater than 6. So what this means is we want to move right pointer to the left of the mid pointer. Now the right pointer is here, left is greater than right, so we return the left pointer, which is 5. Now we have both binary search again, so we add to the result 5 minus 2, which is 3. And now the result is 6. Now the I pointer is here, low will be 3 minus 4, which is minus 1. And high will be 6 minus 4, which is 2. So now we're doing binary search with this value, minus 1, starting from here. So left is here, right is here, mid is here. 5 is greater than minus 1, so we move right pointer here. Now right is here and mid is here. 4 is greater than -1. So now right pointer is here. Now left is bigger than right, so we return the left pointer, which is 3. Now we are doing binary search with 2 plus 1. So left is here, right is here, and mid is here. 5 is greater than 3, so we move right pointer here to left of mid. Now left, right, and mid are here, and 4 is still greater than 3, so we move right to this side. Now right is smaller than left, so we return index at left. High is now 3, and this means we need to add to the result 3 minus 3. So this is still a 6. Now I is here, and low is 3 minus 4, which is -1, and high is 6 minus 4, which is 2. Now we are doing binary search with this part. Left is here, right is here, and mid is here. 5 is greater than -1, so we move right to this side. And now right is smaller than left, so we return the left index, which is 4. And now we do binary search with 2 plus 1. Once again, left is here, right is here, and mid is here. 5 is greater than 3, so we move right pointer over here. And now right is smaller than left, so we return the left index, which is also a 4. And we add to the result 4 minus 4, so this is still a 6. Now the I pointer is here, and low is -2, high is 1. So we are now doing binary search with low, only with the 7. So left, right, and mid are here at the last index, and 7 is greater than -2. So we move right pointer to mid -1, and now right is smaller than left pointer, so we return the last index, which is 5. And now we do binary search with 1 plus 1. Left, right, and mid are here at 7, and 7 is greater than 2, so we move right pointer here. Now right is smaller than left, so we return left. The result of the binary search for high is also 5, and this means we add to the result 5 minus 5, so 6 is still the result. Now we reach the end of the array and we return this. So now let's go with the code, and hopefully you will get the idea. First we want to sort nums, so nums.sort, and initially we will say result equals 0. And now we want to create the binary search function. So binary search, this will take a low, a high, and a target as arguments. And inside here we will say while left is smaller or equal to high, mid equals low plus high minus low divided by 2, and if nums at the mid index is greater or equal to the target, well, in this case we want to update the high pointer to mid -1, so high equals mid -1. Else we update the left pointer, left equals mid +1, and finally we return left. Once we have this, for I in range length nums, we'll create our two variables, low and high, and for each of them we'll do a binary search. So low equals binary search from I plus 1 up to the end of the array. And the target will be the difference between lower and the current value, nums at I. And we will do something similar for high. So high equals binary search from I plus 1 up to length nums minus 1, and we will include the difference between upper and nums at I plus 1. Remember, this plus 1 is because we want to include the upper value. And next we want to update the result by adding high minus low, and finally we return the result. This is the entire code, and let's submit this and see if it works. This target is misspelled, so let's fix it. Now it's target, and try again. And as you can see, this works. So now we'll go with another solution that you might find interesting. Now let's say we're trying to find values that are valid, but only to the upper bound. Let's say we have no lower bounds. Okay, so let's say the upper bound now is 6 plus 1. So we're trying to find every pair that's valid up to an upper bound of less than 7. Okay, so we have no lower bounds, remember that. We'll create a variable, let's call this count up, initially with 0. And we'll say left pointer is here at 0 and right pointer is at the last index. At each iteration we want to add the value at left plus the value at right, in this case 7. And we want to check if that sum is smaller than the target, which in this case is the upper bound plus 1, because remember we are trying to include the upper bound. So we are checking if 7 is smaller than 7. In this case it isn't, so we update right one step to the left. Now right is here, and we are checking if 0 plus 5 is smaller than 7, and it is. So what this means is we can add to our count R minus L pairs, okay, because this is a valid pair, and remember this is sorted, so 0 plus every value in between will also be valid. 0 plus 1 is valid, 0 plus 4 is valid, and 0 plus 4 is also valid. Remember, 0 plus 1 is valid because we don't have lower bounds anymore. We are only checking for upper bounds. Okay, and that's why we want to add to the count a 4. Okay, so 4 valid pairs in this case. R minus L is 4 minus 0. So now the count is 4. Once we find a valid sum, we update the left pointer one step to the right. Now 5 plus 1 is still smaller than 7, so what this means is we are adding to the count 4 minus 1, we are adding a 3, so now count is 7, and we update the left pointer one step to the right. Now L is here, and 4 plus 5 is 9, 9 is greater than our target, which is 7, so we update right. Now right is here, and 4 plus 4 is 8, 8 is greater than 7, so we update right again. Now left and right are equal, so we end this, and the count up is 7. And now we will implement the same with 3 as a target. So we are trying to find every pair that's valid from no lower bound up to a 3. Okay, so we'll create another variable, count down, initially with 0. And we will say left is here, right is here, and now 0 plus 7 is 7, and 7 is greater than 3, so we update right. Now right is here, and 0 plus 5 is 5, and 5 is still greater than 3, so we update right again. Now right is here, 0 plus 4 is 4, 4 is greater than 3, so we update right. Now right is here, and 0 plus 4 again is greater than 3, so we update right. And now right is here, and 0 plus 1 is smaller than 3. What this means is we need to add to our variable count down every valid pair up to the target. So we are adding r minus l pairs, which is the same as 1 minus 0 pairs. So this is now 1. Next we update left, so now left and right are equal, so we end, and now we have 2 values, count up and count down, and the result is just count up minus count down. Okay, so every valid pair up to 7 minus every valid pair up to 3, so result is 6. Okay, so now let's go with the code and hopefully you will get the idea. First we want to sort numbers, so nums.sort, and now we want to create our 2 pointers function, so we'll call this tw from 2 pointers. This will take a target and we'll say low equals 0, high equals length nums minus 1, count equals 0. And while low is smaller than high, we will create a sum variable with nums at low plus nums at high, and each time if sum is smaller than the target, well, this means that we can add to the count h minus l pairs, and we update the left pointer, so l plus equal 1. Else we update the high pointer, high minus equal 1. And finally we return the count. And once we have this, we can return 2 pointers of upper plus 1, because remember we want to include upper, minus 2 pointers of lower. Okay, so this is the entire code. Let's submit this and see if it works. And as you can see, this works and it's very efficient. Time complexity for this one will be big O of n log n. The function runs in big O of n, but remember we are also sorting, so that requires n log n complexity. And about space complexity, I think it depends on the programming language. For example, in Python you can do it in big O of n, but in other programming languages it requires big O of log n. So that's it. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.